I'm Jen and I will be introducing all of you to nanotechnology. And we are going to answer the questions: what is nano? What is technology? What is nanotechnology? And who introduced the nanotechnology? First, we're going to answer the question: what is nano and technology? The term nano refers to the prefix used in the metric system to denote 1 billionth of a unit, while technology refers to the applications of scientific knowledge, skills, methods, and processes to create tools, machines, systems, and products that solve problems, enhance productivity, and fulfill human needs. Nanotechnology. Nanotechnology is a multidisciplinary field of science, engineering, and technology that involves the manipulation of matter at the nanoscale. The prefix nano refers to a billionth of a meter, and nanotechnology typically deals with structures, devices, and systems that have dimensions on the scale of nanometers ranging from 1 to 100 nanometers. At the nanoscale, materials exhibit unique properties and behaviors due to quantum effects and increased surface to volume ratios. Nanotechnology aims to understand and control these phenomena to create new materials, devices, and systems with enhanced properties and functionalities. Applications of nanotechnology span various fields, including medicine, electronics, material science, energy, and more. Examples include the development of nanomedicine for targeted drug delivery, nanoelectronics for faster and smaller electronic components, and nanomaterials with improved mechanical and chemical properties. Who introduced the nanotechnology? The concept of nanotechnology was first introduced by the physicist Richard Feynman in his famous 1959 lecture titled "There's Plenty of Room at the Bottom." In this lecture, Feynman discussed the possibilities of manipulating and controlling individual atoms and molecules to create new materials and devices. Nanotechnology was first coined by Professor Norio Taniguchi in a 1974 paper he presented at a science conference. The paper, titled "On the Basic Concept of Nanotechnology," was published in Science and Technology of Advanced Materials. In this paper, Taniguchi used the term nanotechnology to describe precision machining at the atomic and molecular level, highlighting the importance of working with materials at the nanoscale.
Application of nanotechnology. Here are the five examples that provide concrete technology and equipment. The first one here is the application of nanotechnology. Here are the five examples that provide concrete technology and equipment. The first one here is the medicine. Nanotechnology utilizes particles to target cancer cells and enhance imaging, such as MRI or CT scans. These nanoparticles also enhance contrast and create artificial organs or tissues such as skin, blood vessels, or bones using nanomaterials as building blocks. 1% example of nanotechnology in medicine today is electrospan polysaccharide nanofibers, which combine the characteristics of polysaccharide and electrospan nanofibers. They have the function of hemostasis, absorption, breathability, bacteriosis, anti-inflammation, and promotion of cell proliferation and tissue remodeling when used as a wound dressing. Second, diagnostics. Nanotechnology enables the creation of devices that accurately detect and measure biological molecules like DNA, proteins, and viruses. This is done through using techniques like nanotechnology on a chip for genetic testing, disease diagnosis, and environmental monitoring. 1% use of nanotechnology in diagnostics today is for the detection of diabetes, which uses carbon nanotubes that utilizes glucose as its detection analyte. Third, tissue engineering. It would also a big help in tissue engineering, repairing or regenerating damaged or diseased tissues. It creates biodegradable, biocompatible scaffolds for cell growth, support artificial organs like heart, liver, and kidney, and it also heals wounds. Carbon nanotubes, dendrimers, and liposomes are important tissue engineering scaffold materials and drug delivery systems which deliver drugs to impaired tissues. Fourth, environmental friendly energy systems. Nanotechnology can enhance energy conversion efficiency, reduce environmental impact, and create new energy sources like solar cells, fuel cells, batteries, and supercapacitors. It can also create nanomaterials to reduce pollutants from combustion engines and power plants. Air purification with ions, wastewater purification with nanobubbles, or nanofiltration system for heavy metals are some of nanotechnology's environmental friendly applications, along with nanocatalysts that are available to make chemical reaction more efficient and less polluting. And lastly, construction. Nanotechnology enhances building performance, durability, and functionality by creating new materials, processes, and systems. It can enhance concrete, steel, and wood strength, create nanosensors, robots, and machines, and create nanocoating for protection against dirt, water, and bacteria. Among the many types of nanoparticles, nanotechnology-based concrete additives like nanosilica and nanotitania improve the toughness and longevity of concrete, reducing the amount of construction waste brought on by early material failure.
Another application of nanotechnology is vehicle manufacturing. Nanotechnology enhances vehicle performance, safety, and efficiency by creating new materials, components, and systems. Nanocomposites like carbon nanotubes and graphene reduce weight, increase strength, and improve conductivity. Nanosensors, robots, and machines monitor and optimize vehicle operations. Nanocoatings protect vehicle surfaces from damage or weather. Next application is household. Nanotechnology enhances household convenience, comfort, and quality of life by creating new products, appliances, and devices. Nanomaterials like nanoceramics and nanosilver improve smoothness, heat resistance, and antibacterial properties. Nanosensors, nanorobots, and nanomachines automate appliances, while nanocoatings maintain cleanliness and freshness in household items. Next application is textiles. Nanotechnology also enhances textile comfort, functionality, and appearance by creating new fabrics, fibers, and garments. Nanofibers increase strength, elasticity, and conductivity, while nanomaterials impart properties like water repellency, stain resistance, and odor control. Nanocoatings protect textiles from dirt, bacteria, and sun damage. Next application is cosmetics. Nanotechnology enhances the quality, safety, and effectiveness of cosmetics by creating nanomaterials that deliver active ingredients, provide UV protection, and enhance color, shine, or texture. Nanoparticles, nanocapsules, titanium dioxide, zinc oxide, and gold or silver can deliver active ingredients, protect against UV rays, and enhance cosmetics. And lastly, agriculture. Nanotechnology enhances agriculture productivity and quality and sustainability by creating nanomaterials for precise fertilizer delivery, nanosensors for disease detection and treatment, and nanomaterials for improved preservation, processing and packaging, and transportation of agricultural products like fruits, vegetables, and meat. This technology also improves the quality and sustainability of agriculture.
So, good day, and for this slide, we will be talking about the positive effects of nanotechnology in the environment. So, let's start. First of all, these tiny particles are called nanoparticles. These are the key to nanotechnology. These tiny particles, my bad, are millions of times smaller than the width of a hair, and it makes a positive effects on nanotechnology, which helps to clean up water, make the energy sources cleaner, and protects every food from harmful substances. Let's proceed. So below are the following positive effects of nanotechnology on the environment. So first, nanotechnology removes harmful substances like heavy metals, pesticides, and bacteria from our drinking water. It is also used to create special surfaces, that repel water and prevent the growth of algae and other microorganisms, which means it results to cleaner water for drinking and swimming and other activities. Now for the next part is that nanotechnology helps to develop cleaner energy sources, and nanoparticles can be used to make solar cells more efficient and less expensive, which means that nanotechnology also improves the performances of batteries and other storage devices, energy storage devices, things like those, which means that people can rely less on fossil fuels and reduce the impact of climate changes, which is highly needed for our current situation. Now, for the last part, nanotechnology is used to clean up pollution in soil, water, and air. Wow naman. So, nanoparticles can absorb and remove pollutants, and it can also break down pollutants into harmful substances, which then make a cleaner air to breathe, cleaner soil to grow food, and cleaner water to drink or to swim on. So, nanotechnology have different use. I'll state the following. So, first of all, nanotechnology is being used to improve our food supplies. These nanoparticles can be used to develop fertilizers and pesticides that are more effective and less harmful to the environment. They can also be used to improve nutritional value of foods and extend their shelf life, which means it is healthier and less waste food for our planet. As you can see, nanotechnology is a really powerful tool that can help to address some of the most pressing environmental challenges on our time, which continued research and development. We can expect to see even more innovative and effective solutions that is to emerge in the years to come.
Understanding of the environmental effects and risks associated with nanotechnology is very limited and inconsistent. The potential environmental harm through nanotechnology can be summarized as follows. High energy requirements for synthesizing nanoparticles causing high energy demand. Dissemination of toxic, persistent nanosubstances originating environmental harm. Lower recovery and recycling rates. Environmental implications of other life cycle stages also not clear. Lack of trained engineers and workers causing further concerns. Nanoparticles are like tiny helpers that can clean up messes and make things better. Surprisingly, nanomaterials have been developed for use in many applications that clean up pollutions and contaminants. However, other studies have shown that some nanomaterials can actually damage the environment. Some recent findings on environmental contaminants have demonstrated a severe damage to marine organisms by nanoparticles released in nature as waste. Studies have shown that exposure to this type of nanoparticle can lead to increased cytotoxicity and oxidative stress in marine microalgae and copepod organisms.
Scientists have found that when these tiny helpers get into the water, they can make it harder for tiny plant-like things called microalgae and tiny shrimp-like creatures called copepods to live. Other studies revealed that the buildup of nanoparticles in the soil, especially copper oxide, titanium oxide, cerium oxide, and nickel oxide, can reduce the rate of photosynthesis and can make it harder for plants to grow. Further studies are necessary regarding the effect of nanoparticle pollution on the environment. Nevertheless, it is apparent that due care should be adopted while using nanoparticles and nanotechnology to avoid the release of nanomaterial into the environment. In addition, guidelines to protect the environment from the effect of this type of pollution should be put in place. After the amount of damage has been caused by the nanoparticles in this environment is measured, we will be able to come up with such guidelines.
Educational issues. Point 1. Adjustment. We'll have to respond to the change in dynamics and composition of the workforce. This is to change curriculum to match changes in society with emphasis on science, technology, and engineering fields. Recent advances in envisioned developments in enabling nanotechnology provide challenges to the academia in educating and training a new generation of skilled engineers and competent scientists. These engineers and scientists should possess the ability to apply knowledge of mathematics, science, and engineering in order to design, analyze, and fabricate nanodevices and nanosystems, which are radically different when compared with microdevices and microsystems. Atomic and molecular compromise nanodevices and nanosystems exhibit distinctive quantum phenomena and unique capabilities that must be utilized. Point 2. Changes could result in changes in the classroom. Although technologies became prominent in the pandemic, we still couldn't deny that further integration of nanotechnology would be harder to blend in. Point 3. Lack of information and hands-on learning. Researchers or college students do not fully realize and understand how nanoparticles affect a system. Access to nanotechnology are limited. Point 4. Promote students' reliance to nanotechnology. Nowadays, there's a lot of automized educational systems that have proved to be extremely efficient. Thus, there is no way to deny that the student of the nearest future will be taught by robots. Ozel, 2008.
To conclude, we cannot deny the fact that nanotechnology has provided mechanisms for easier and faster learning experience. But we also cannot deny that some students lack the capacity to keep up and are being left out mostly due to lack of resources. If nanotechnology would bring about changes in our curriculum, not only the students but also the teachers and school departments will have to comply with vast adjustments. For example, the changes faced by students in the implementation of blended learning were seen during the pandemic. This is where the problem of internet connection and gadgets arose, which affected not only the educational sector but the whole country. There were multiple students that chose to give up studying, although unwillingly, because they could not afford to supply themselves with the necessary devices for education. Not every school has laboratories specifically for science and technology. For this reason, students could not personally study nanotechnology. Although books and the media provides all information and images, it's still different when students can work on it themselves. Because of the various apps developed specially for students, we could not help but utilize this to our advantage. However, this could not help us for the better at all. It proved to have negative impact as we are becoming too dependent on these technologies. It should be limited and students should be taught how to utilize them efficiently and effectively.
The manipulation of matter at the nanoscale is the focus of the multidisciplinary field of nanotechnology, which encompasses science, engineering, and technology. It is described as a small solution to big problems given its innovation despite its size, as its size gives it the ability to be more efficient and cost-effective by utilizing nanoparticles in combustion processes, which lowers emissions and fuel consumption, resulting in optimized energy production. Nanotechnology can be applied in various fields like medicine, diagnostics, tissue engineering, environmental friendly energy systems, construction, agriculture, electronics, and etc. Nanotechnology also promotes positive effects to the environment as it has the potential to reduce human footprint on the environment by providing solutions for energy consumption, pollution, and green gas emissions. Nanotechnology also aims to target affordable and clean energy by improving solar energy as it has the ability to enhance energy conversion efficiency and can create new energy sources like solar cells and supercapacitors. Clean water and sanitation can also be achieved with the help of nanotechnology. This is through the use of nanobubbles and nanofiltration, with the purpose of water purification. Nanotechnology is also one step ahead of industry, innovation, and infrastructure, since it enhances building performance, durability, and functionality. The strength of steel, concrete, and wood can all be increased by nanotechnology. It can also be used to develop materials with nanocoatings that is used as protection against bacteria, water, and filth, as well as nanosensors, robots, and other machinery that are meant to be used in the construction of establishments. While nanotechnology does show the capability of developing a healthier environment, it still has negative effects to the environment given the associated risk to nanotechnology. Also, despite the many benefits that nanotechnology can offer to different fields, there is still an inflection in the educational capability that this may be available to all learning institutions due to the lack of resources. Finally, since nanotechnology is a sophisticated interdisciplinary field that combines science, engineering, and technology, it is one that should be investigated by both seasoned researchers and novices in order to advance our understanding of science and technology, and more importantly, to enhance our quality of life.